Particles of different sizes are removed by different physical mechanisms in a Baghouse filter and rigid barrier filter. There are 5 mechanisms that involve in the collection of particulates in filter Baghouse. They can be distinguished as gravity, initial impaction, interception, Brownian diffusion, and electrostatic attraction. The main key in designing a baghouse is to calculate or to determine the gas to cloth ratio, in which it will produce it must be in optimal balance between its pressure drop, which will affect its operating cost, and baghouse size, which will affect the capital cost. For the mechanism of capturing particles in filter and baghouses, the largest particle will experience a gravity force in which it will determine their trajectory. So largest particles will tend to falls down before it is hitting the fiber of fibril. For the much smaller particles, which is about 1 micron, the mechanism of collection of particulates is by the initial impaction, in which smaller particles may not be able to follow the trajectory of gas flow, so they will hit the fiber or fibril. Unlike some of the particulates devices that we have already learned previously, in filter baghouse there are multiple opportunities for particle impaction because of numbers of individual dust cake particles and fabric fibers or fibrils for the gas stream to encounter with. Particles may also become in contact with the fiber collector. The streamlines of the gas flow are contracting when passing the fiber, which leads to interception of the particles. For the finest particles, it is removed normally by diffusion as a result of random motion of Brownian. And the last mechanism may be effective when the electrostatic forces are generated between the particles and the collectors due to the particle charging. Okay, now I will demonstrate how can we derive a model from the analysis of cake filtration. Flow through a simple filter is shown here, in which we have initially we have filter medium without the filter cake. So after some times, some particulates that cannot go or pass through the filter medium. Filter medium can be a piece of cloth, paper, porous metals, or bed of sand. So particles yang tak boleh pass through this filter medium will be accumulated from time to time and will form a filter cake. The clean gas free from solids will flow through both cake and filter medium. Thus filter cake pun will act as a filter lah, will involve in the filtration process. Okay, so tadi the tea gas stream therefore will have to pass through the filter cake as well as the filter medium. So meaning that more finer particulates will be collected lah. Okay, after some filter cake formation appears, okay, so a small change in velocity will happen because of due to increment in the pressure drop. So bila ada pressure drop ni increase, so velocity will be slower because of dia kena pass through this filter cake. I'm going to show you how to derive a model from the analysis of cake filtration, okay, in the filter baghouse filtration process. Okay, let's look at the diagram shown here. Initially, when there is no filter cake formation appears, we only have filtration process due to filtering medium. Okay, so filtering medium having a certain pore ataupun diameters of pores that will retain some larger particulates from passing through the medium lah. Okay, so yang mana yang kecil-kecil, so particulates, small particle will pass through. So initially lah. Okay, now after some times, okay, when the bigger particles, okay, keep accumulating, okay, at the surface of the filtering medium, okay, so they will form a cake. Okay, dia akan form filter cake. So filter cake here will also act as a filtration process atau filtering medium juga to filter much smaller particles. So bila ada cake, so much smaller particles cannot pass through the filtering medium. Okay, so meanings that in filtration process dalam filter baghouse, we are depending on two layer of filtration, which are the filter cake and also from the filtering medium. Now, if we follow the gas stream from point 1 to 2 to 3, okay, we see that the flow is horizontal. Okay, so we assume the flow is horizontal and has small change in velocity. So smaller velocity change when it passes through the cake as well as the filtering medium because of the increment in the pressure drop. So bila filter cake form, so the delta P will increase. Okay, this makes the flow ataupun velocity of gas flow become slower. The gas has to expand because gas to leaving behind smaller particles and also the larger ones lah. Okay. In analysing the cake filtration, sebab apa kita panggil cake filtration? Because cake filtration plays much more important roles in filtration process dalam filter baghouse because more particles will be collected ataupun will be retained due to the filter cake, bukan due to filtering media sahaja. Okay. So according to Darcy's law, okay, Darcy's law. So Darcy's law, the flow in a porous medium is given by this equation. Okay, the velocity equals to the flow rate that pass through the these two boundaries of filtration layers. Okay, so kat sini kita ada dirty gas lah. So bila dia pass through these two layers, we will get cleaner gas. Okay, it will because those particles yang kita nak filter tadi will be left behind. Okay, and then the flow rate, okay, divide with the surface area. Berapa keluasan yang the flow pass through. Okay, and this is equivalent to the Darcy's law of flow in a porous medium. Okay, given by negative delta P, negative pressure drop over mu times K over delta X. So delta P here is the pressure drop. So kalau kita tengok kat sini, since dia ada dua boundary atau dua layer, so we have to do some analysis for both layers lah. Okay, so meaning that pressure drop untuk filter cake will be separately done for pressure drop through the filter medium sebab lain-lain. Okay, so pressure drop is the differences between P2 minus P1. Okay, since there is a negative signage here, so dia akan jadi terbalik, in which P1 minus P2. So we may write this as P1 minus P2 over mu times K over delta X. Okay, K here is the permeability. Okay, permeability is a property of the bed ataupun filter medium lah. Kalau dia dalam bed, atau bed means cake lah. Okay, kalau dia dalam cake, so K is the permeability of the cake. Kalau kita referring to the analysis of filtering media, so K is the permeability for the filter medium. Okay, and delta X here is the thickness of cake. Okay, sebab yang first tadi kita buat cake analysis. Okay, and then secondly, bila kita buat filter medium punya analysis, okay, we may write it as P2 minus P3 pula. P2 minus P3 over mu times K over delta X, and this is belongs to the filtering media. Okay, Vs here is also known as air to cloth ratio. Okay, normally it is called as air to cloth ratio. Okay, now we're going to rearrange this equation so that kita boleh gabungkan expression in cake with the expression with the filtering media pula. Okay, now here dalam these two expressions, we can see that similar variables is the P2. Okay, so P2 is the similar, sama lah, the same variable. Therefore, okay, we want to express all these equations ataupun expressions in terms of P2. So we may rearrange this into P1 minus mu Vs. You can try this one by yourself. Okay, and then another expression for filter medium pula is P3 plus mu Vs delta X over K of filter medium. Okay, therefore, the first equation can be substituted into the second one. So we will get equals to P1 minus mu Vs, the expression in the cake ataupun bed. Okay, next we want to solve for Vs. Okay, sekarang nak solve for Vs. So you can try this out, try on your own. So in the end you will get Vs equals to P1 minus P3 over mu times the expression from cake analysis and the expression from the filter medium analysis. Alright, now you can see ada dua, okay, we call it as resistance. Ada dua resistance expressions here. The first one we call it as cake resistance, and the other one is we call as cloth resistance because of resistance to the flow due to the filter medium, and untuk cake resistance of flow due to bed of cake tadi, okay, ataupun particular accumulation. Okay, untuk filter cloth here, it is can be replaced with the symbol alpha. Okay, because alpha here ataupun cloth resistance will not be changing due to time. Sebab, okay, filter medium tadi atau dalam contoh kita cloth, filter cloth, okay, dia punya thickness tu akan increases tak kan? Okay, it will be the same even after some time, sama je filter cloth tu. However, what will be changing? Okay, this delta X atau dalam cake layer ni akan changes due to ataupun depending on the dirty gas dan juga component of particulates loading tadi. Okay. Tadi saya kata filter cloth ataupun cloth resistance dia is not changing with time, so kita assume it as constant. Dia constant. And independent of time. Independent of time. We're going to do the analysis on cake sahaja, because yang ni constant, so we cannot do anything about this. That is why analysis untuk menghasilkan model ni dipanggil cake analysis ataupun analysis of cake, because cake formation tadi will be changing with time ataupun depending on time. Now in case 1, let's see if the formation of cake is consistent. Let's say if the formation of cake is consistent and uniform. Kalau katakan cake punya formation tadi consistent and uniform, the cake thickness, cake thickness delta x untuk cake tadi can be expressed as m over a times 1 over rho of cake. Because delta x tadi adalah volume of gas pass through the cake per area. Volume per area. And kita tahu volume ni adalah volume per area. Gas volume per area. And volume is given by m over rho. M over rho. Ni comes from m is rho v kan. So v volume is m over rho. So that's why kita gantikan m over rho and over time. M over rho over time. So this will give you delta x. Delta x is, we can write this as 1 over rho cake times mass of solid. M is the mass of particles that is retained on the surface, ataupun some authors refers it to mass of particles or solids that is removed. Over volume of gas times, yang ni kita boleh pecahkan lagi. Volume of gas over since m over a, so volume of gas over area, filter area. Alright, because these two can be cancel off, so hanya akan tinggal m of particles over a. It will gives you the original equation lah untuk delta x. Now if we look at these two, kalau kita tengok these two, we know that rho cake is also termed as mass of cake over volume of cake. So kita boleh gantikan dia mass cake, mass cake is ataupun mass of particles lah, sama. So mass cake over volume, so volume will go up, times MP here is m cake lah, it's the same, and volume of gas. So this can be cancelled off, so we will get actually volume of cake over volume of gas that will pass through. So apakah ini sebenarnya kalau dalam konsep particle removal atau particles collection? Ingat tak lagi? M collected over M initial. Okay, M1. M collected over M1. So this is efficiency. Betul tak? Okay, so sama juga dalam konsep ni. So therefore kita nak gantikan these two with W. Okay, W times berapa efficiency dia. Okay, so kita kena bagi dia simbol. Alright, so now we can rewrite the whole equation here as W, okay, times volume of gas over A. Okay, now if we assume that, okay, alpha eta is equal to 1, meaning that 100% particles yang brought by the gas streams will be collected. Okay, semuanya akan collected. So we can say, we can write it as WV over A. Okay, now we have this expression of delta X. So kita nak masukkan delta X ni dalam equation yang kita dah hasilkan tadi. Okay, to get the model lah. Okay, so now I'm going to write the Vs punya expression again here. P1 minus P3 for cake, for filtering media. And you may also replace this with alpha, sama. Okay, so now we want to substitute delta X in this equation. Okay, we may write again Vs tadi is equivalent to Q over A, P1 minus P3 mu delta X kita adalah WVA, WV over AK. So this is belong to cake. And alpha, okay, alpha, just write this as alpha lah, okay. Alright, okay, so now kita nak, okay, now we also know that Q tadi, Q, okay, kalau if we differentiate Q, we will get dV over dt. Betul tak? Q is dV over dt. Okay, kalau kita bezakan Q, we will get dV over dt. Sorry, kalau kita integrate. Okay, alright. Now we want to replace Q here, 1 over A dV over dt. Okay, V here is V of gas. Okay, saya nak guna V gas ni. Okay, so sekarang we want to bring all of this to the left hand side and dt to the right hand side so that we can start do some integration to this model atau equation. Okay, so kita bawa ini ke sini, so we will get mu WV over AK, okay, 1 over A plus alpha P1 minus P3 dt. Okay, okay, since kita ada dua expression ni, so kita nak bahagikan lah. Okay, mu over A square K W V dV plus alpha dV. Okay, so now we are going to do some integration kepada this equation ataupun expression So bila kita integrate, we will get mu w v square over 2 ka square plus alpha, alpha tadi lupa ada 1 over a here, alpha over a. Okay, so alpha over a v equals to p1 minus p3 t. Okay, so if you can see here, kita ada dua v over a punya expression. So therefore, kita boleh pecahkan mu w over 2k v over a square plus alpha v over a okay. So if you look at this expression carefully, okay, you will know that ataupun you will notice this is a linear equation. Linear equation in which, okay, mu w v over 2 ka times v over a plus alpha v over a equivalent to p1 minus p3 t. So apa? So this becomes you punya x-axis, this is your y, and this is your m, which is the slope, and this becomes your c, intercept y. Okay, so you will get y equal to mx plus c punya expression. Okay, okay, therefore this will enables you to calculate ataupun to determine apakah k and apakah alpha. Okay, so macam mana? So you have to plot a graph of y versus x. So in which you punya y is p1 minus p3 t, okay, and you punya x is v over a. Okay, okay, now let's look at this model that we have already established or derived here. Okay, for many filtration, the resistance of alpha here, which is the cloth resistance, it is normally negligible because if we compare alpha to the cake punya constant, it is very low atau too small. Okay, so in such cases, okay, kalau if it is too small, okay, alpha can be assumed negligible or equal to 0. So these terms akan jadi 0. So we will get v square is directly proportional to t. In such cases, in these cases, we can say that volume of gas process is proportional to the square root of the time of filtration. So T is the time of filtration. So this is the case of constant pressure. Okay. Now, for some industrial gas filtration, a positive displacement blower, which is practically a constant flow rate device, okay, seperti yang saya ada tunjukkan dalam types of filters. Okay, for some industrial gas filtration, okay, in which we have a blower in front of the baghouse. Okay, so this kind of equipment ataupun blower ni is practically a constant flow rate device. Tadi kita buat analysis on constant pressure. Now kalau kita nak tengok on constant flow rate condition pula, in which condition it explains dalam apa ni positive displacement types of filter baghouse. Okay, So bila blower ada kat sini, so we will get a constant flow rate condition. Okay, and these flow rates will fix the filter at a pressure that steadily increases during the filtration. So tadi pressure ataupun pressure drop tadi constant, now pressure drop will increases. Okay, so for constant K, okay, and negligible, we must assume negligible alpha, must assume that K adalah constant dan alpha again negligible bila compared to the permeability atau constant by the cake filtration. Okay, alpha tu can be neglected because of dia sangat kecil. Okay, for that, okay, let's look at the equation again. So yang ni akan jadi kosong and K is constant. So we may have a condition ataupun expression that delta P, negative pressure, okay, negative pressure drop is actually increases linearly. So dia linear. So delta P increases with time. Okay, this is because the cake thickness increases linearly with time. Because of the cake thickness increases linearly with time. Okay,